Let us see the reverse heat engine. Reverse heat engine. Reverse heat engine. How heat engine works? Heat engine has three parts. One is hot reservoir, next one is working substance, and the third one is cold reservoir. Always the working substance absorbs heat from the hot reservoir and it does some work, or it moves the piston, and some amount of heat energy is rejected to the sink. Q2 is the amount of heat energy rejected to the cold reservoir, Q1 is the amount of heat energy absorbed from the hot reservoir. This is the process which occurs in case of heat engine. Reverse heat engine, that means here the working substance absorbs heat from the cold reservoir and then it releases some excess heat energy to the hot reservoir. This is possible. Naturally, this process is not possible. This is possible only if work is done on the system. If we do some work on the system, then only, or if the external work is done on the system, then only it is possible to transfer heat from colder object to hotter object. Let us see how it is possible. Here in case of reverse heat engine, we have the working substance, and here we have the cold reservoir which is at temperature T2. At temperature T2, and here we have the hot reservoir which is at temperature T1. T1 is greater than T2. Reverse heat engine, reverse of heat engine, that is this working substance absorbs heat from the colder object. Q2 is the amount of heat energy absorbed from the working substance, absorbed by the working substance. Q1 is the amount of heat energy rejected to the hot reservoir, that is Q1. This is possible if we do work on the system. External work must be done on the system. So, here we have work done on the gas or on the system. If external work is done, then it is possible to transfer heat from cold object to the hotter object. So, this is about reverse heat engine. So, on this principle refrigerator works. So, refrigerator works on this principle. So, it works on the principle of reverse heat engine. So, what is refrigerator then? Refrigerator is a device, it is a device which acts in the reverse direction of heat engine, reverse direction of heat engine. So, refrigerator is a device which acts in the reverse direction of heat engine. That means it absorbs heat from the cold reservoir and releases heat to the hot reservoir. So, this is the schematic diagram of reverse heat engine or the refrigerator. This is the schematic diagram of refrigerator or the reverse heat engine. So, reverse heat engine always absorbs heat from the colder object and releases heat to the hotter object. So, it absorbs heat from colder object and releases heat to the hotter object, hot reservoir. So, this is the statement of refrigerator and this is the schematic diagram of reverse heat engine or refrigerator. Let us see how refrigerator works, how this refrigerator works. For that, consider this. Here you just imagine that this is the refrigerator, inside view of refrigerator. So, this is the pipe where the gas is carried from one point to another point. Here we have a pipe and which is connected to a compressor. So, this is called compressor, which is connected to this point. So, this is the inside view of refrigerator. Here we are keeping some utensils filled with food. Here gas is there. Which gas we are considering in case of refrigerator? We are considering the freon gas. So, when this gas or when this freon gas enters here or when this gas comes here, the gas expands, right. So, till this point the gas is compressed. The gas is compressed here inside the pipe, it is compressed. So, its temperature is also high. When it reaches this point, when the gas suddenly enters this point, the gas expands because there is lot of space. So, it can move easily. So, it expands. When it expands, its pressure decreases, its temperature falls or its temperature also decreases. So, temperature decreases. After that, the gas absorbs heat from the region to be cooled, which is nothing but the food which is kept inside the refrigerator. So, the gas absorbs heat energy from the food. The gas absorbs heat energy from the food. Our aim is to cool the food. So, it absorbs heat energy from the food and the gas comes here. When it comes here, it again its pressure increases. Again its pressure increases. When pressure increases, what happens to temperature? Temperature also increases slightly and the gas comes here. When it comes here, there is a compressor. What is the job of this compressor? This compressor compresses the gas. When it compresses, again there is increase in pressure and increase in temperature. So, this is the atmosphere. Atmosphere is a temperature 30 degrees Celsius. Say atmospheric temperature is 30 degrees Celsius. Here Inside the compressor, the gas is compressed, its pressure increases, temperature increases. So, here the temperature of the gas is T1. So, this T1 is greater than the atmospheric temperature. So, this is the atmosphere. Atmospheric temperature is less than the temperature of the gas. What happens naturally? Heat energy flows from higher temperature region to lower temperature region. So, it starts radiating the excess heat energy. So, excess heat energy is rejected or releases to the atmosphere. So, excess heat energy is released to the atmosphere, and this gas, after releasing the excess heat energy, again comes here. When it reaches here, its temperature decreases, decreases, decreases. When it comes here, its temperature may be somewhat equal to the atmospheric temperature. Again the process continues. The gas, when it enters here, it expands. When it expands, its pressure decreases, temperature also decreases, and then the gas absorbs heat energy from the food. Its temperature slightly increases, and when it comes here inside the compressor, the gas is again compressed, pressure increases, temperature increases suddenly. So, there is increase in temperature. This temperature is greater than the atmospheric temperature. Due to this temperature difference, heat energy is radiated out or radiated to the atmosphere, and finally it comes here, and again the process continues. So, this is the working of refrigerator. So, I will write some points. So, this is not there for the exam. In the examination, if they ask you to write the working of refrigerator, you should not write this. This is only for your reference. Okay. I will point out, or I will give some points. Along with that point, you have to draw this schematic diagram. That is enough for the exam. This is only for your understanding. First one is, what happens here? Sudden expansion of gas. Sudden expansion of gas. When gas expands, its pressure decreases. So, sudden expansion of gas from higher pressure to lower pressure. When gas expands, its pressure decreases. So, from higher pressure to lower pressure. When temperature falls, the gas may reach its liquid state. Here not the liquid state, here there is a combination of vapor and liquid mixture. So, on expansion, sudden expansion of gas from higher pressure to lower pressure, and there is vapor liquid mixture. When the gas cools, its state changes, or when the temperature decreases, vapor may be transformed into vapor liquid mixture. This is the first point. Second point is, okay, when the gas enters the refrigerator, it expands suddenly, so temperature falls, so it is converted into vapor liquid mixture. After that, what happens? What is the second process involved? Second process is absorption of heat from the region to be cooled. So, absorption of heat from the region to be cooled. That means from the food, and converting into vapor. Again it is converted to vapor, that is on absorption of heat from the food, its temperature again increases. So, from vapor liquid mixture to vapor. So, and converting into vapor state. This is the second process involved. Third one is, who is doing the work here? Compressor is doing the work, otherwise it is not possible to reject heat to the atmosphere, absorbing heat from the colder object, releasing heat to the hotter object. It is not possible unless some work is done on the system. Here, in case of refrigerator, compressor is doing work. So, inside the compressor, the gas is heated up. So, heating up of vapor and work done on the system. Work is done on the system. This is the third process. Fourth process involved is, what is the fourth process? Releasing heat to the surrounding and bringing the system to its initial state. So, these are the 4 steps involved in case of refrigerator. If in the examination this is a question, or if the question is like this, explain the working of refrigerator, then you have to write the sentence and then this schematic diagram, after that these 4 points. So, this question may be asked for 5 marks. So, this is important question. So, always work is done on the system in case of refrigerator, reverse heat engine. Q2 is amount of heat energy absorbed, Q1 is amount of heat energy released to the hot reservoir. Here hot reservoir is nothing but the atmosphere. Hot reservoir is nothing but the atmosphere, cold reservoir is nothing but the food. Okay. So, we are absorbing heat from the food and releasing it to the atmosphere. So, Q1 is amount of heat energy released, Q2 is amount of heat energy absorbed. So, this is the working of refrigerator. Next one is efficiency. Take down. In case of heat engine, quality of the heat engine is measured in terms of efficiency. So, efficiency of the heat engine, eta is equal to work done divided by heat input, that is eta is equal to W by Q1. Here in case of refrigerator, quality of the refrigerator is measured in terms of coefficient of performance. Here we are not using the word efficiency, here we are using the word coefficient of performance. So, the coefficient of performance of the refrigerator, coefficient of of performance in case of refrigerator or the efficiency of the refrigerator. Coefficient of performance of the refrigerator is denoted by the symbol alpha. It is denoted by the symbol alpha. So, alpha is equal to, it is the ratio of Q2 and W. What is Q2? Q2 is the amount of heat energy absorbed from the sink. What is W? W is the work done on the system. Work done on the system. Q2 is the amount of heat energy absorbed from the sink or from the cold reservoir. So, in the schematic diagram we have seen that. So, this is the working substance. Here we have the cold reservoir and then we have one hot reservoir which is a temperature T1, here it is a temperature T2. Q2 is the amount of heat energy absorbed, Q1 is the amount of heat energy released. Here work is done on the system, W. So, this W plus Q2 is equal to Q1, right. So, this is the input, this is the input. So, W from this I write W plus Q2 is equal to Q1 or W is equal to Q1 minus Q2. W is equal to Q1 minus Q2. So, alpha is equal to Q2 divided by W. W is Q1 minus Q2. So, this is the expression for coefficient of performance of refrigerator. This may be asked for 1 mark. What do you mean by coefficient of performance in case of refrigerator? So, the statement is like this. It is, or coefficient of performance is the ratio of, it is the ratio of heat energy absorbed from the sink or the cold reservoir to the work done on the system. Here also efficiency cannot be equal to 100%. So, this is the formula for coefficient of performance, Q2 divided by W. So, there is no SI unit for coefficient of performance because Q2 is the heat energy, W is the work energy, both are energies. So, their units cancel with each other, alpha has no unit. So, it is a ratio of heat energy absorbed from the sink to the work done on the system. So, this is important for the exam. If the question is like this, what do you mean by coefficient of performance of refrigerator, and write the expression. So, at first you have to write this statement and then you have to write this formula, alpha is equal to Q2 divided by W. Okay. So, this is in terms of heat energy. So, in terms of temperature, the expression for coefficient of performance alpha is equal to, here we have Q2, so T2 divided by, instead of Q1 we have T1 minus T2. So, this is the expression for coefficient of performance in terms of temperature.